All right. Thank you, Tony, Jeff, and Danny, for those insightful talks. Just to kick off the discussion, I'm going to go back to something that Jeff shared, which was you talked about the technology architecture and what goes into the system, and you said, well, we could replace this with just this deep neural net. And I recollect reading probably earlier this year this news story of NVIDIA test driving a vehicle in New Jersey where the entire motion planning system, the decision engine, what they were calling the driving policy of the vehicle was completely self-learned. And I think of that as phenomenal that you could pull something like that off, but I contrast it to perhaps the other end of the spectrum. And Danny, in your slide, you had the different startups working in this space. You had Newtonomy, and that's a company that's got a driving system, a driving policy that's completely rule-based. It's a hierarchy of rules. People programming these rules, two extremes of the spectrum. And I'm curious, how do we think of the trade-offs between these two extremes, especially as it relates to having a deep neural network that's doing a great job in practice, but we don't know exactly why and how it's making decisions, and that becomes an issue when things go wrong. So I'll maybe pose that question to Danny.
Yeah, so as background, we have one of our research facilities is in New Jersey, and they have a fleet of cars out there. We're testing in California and Germany and Japan as well. But this research group basically did exactly what Jeff had in his diagram. We had just, in this case, with just cameras, camera-based, and that front-facing camera was the input, and we basically correlated that to how a professional driver steered. And we drove the car just 3,000 miles, and it was on country roads, it was on the Garden State Parkway, and just got a lot of data. But in the whole scheme of things, it's not that much data. But remarkably, it was able to do an incredible job of driving based on that limited training set. And the beauty of it was we hadn't explicitly trained it to read lanes, and we hadn't explicitly trained it to recognize cars or pedestrians or anything. But it naturally figured out what was important and what wasn't important. It was able to drive, even if there were no lane markings. Like on a country road where there were no lane markings, it still could drive. And had we essentially programmed it or even trained it specifically for lane markings, it would have failed. But I think the critical thing is that it's not that we would want this sort of end-to-end deep learning method to be the only technique used, but this complements having specific detectors where we're trying to identify certain objects. We couple it with this pilot net, and we have a free space or open road net. And so multiple neural nets all together are giving us much better information. And like you said, then you couple that with the ability to have specific rules-based policy. We get information from the map that shows where a stop sign is. And so we know you need to stop at a stop sign. And you need to stop for pedestrians in a crosswalk. So all these other things are set rules, and then the AI augments that.
Okay. So you're describing multiple neural net, multiple rules. So really, there's a lot of redundancy baked into the system, which I imagine is how Uber's approaching it. And maybe, Jeff, you can talk about what redundancy does also from perhaps a security standpoint, and what are the implications of having that much redundancy?
Yeah, I think, and actually I just wanted to add one thing to what Danny said. Of course, I think there's an idea that ultimately these approaches will be used in conjunction in many different ways, but it is fun to debate the sort of the pluses and minuses of each. And one of the criticisms of the all deep learning approach is that there's so many corner cases, so many rare things, that you may need an exponential amount of training data in order to actually train your net to do this. But it's interesting because there's a flip perspective to that, which is if you look at the more engineered system, the more decomposed system, to cover all those corner cases, you keep adding in more conditions, more boxes, which means more interactions between all the components of your system. And I would hypothesize that it's possible that you will need an exponential amount of engineering effort to get all of those right. And so I regard it as a little bit of an open question yet as to which of these will really will really get us to the very end the fastest. I think it's quite interesting.
I mean, one of the cool things that we've seen too is as we're going through this process, it's an iterative process. It's not like we said, okay, we're done, we're putting the car out there. And so all of this testing that's going on, these cars, even if there's a corner case that you haven't seen before, you know that there's something there and you know that you need to stop or you need to go around it or something like that. And what you can do is the system knows what it understands, and then it easily knows what it doesn't understand. And so all that information comes back to the cloud, right? We can instantly see, okay, there's a deer in the road, and maybe we never trained it on a deer, and so at that point we can go get a lot of data on deer and moose and cows and other large animals and add that to the system, do an OTA, and now we have large animal detection in the system. And so I think that's the exciting part of how quickly we can iterate. And I know that's what Tony, you guys have been able to do. Full disclosure, we invested in Jingqi, right? And they're
Thanks a lot. Really appreciate NVIDIA investing in us.
and NVIDIA, again, we're not building the cars, but we do invest in a whole variety of different companies that are helping to really advance the state of many industries, but transportation in particular.
Well, obviously, one of the things that it enables also is speed and time to market, having this deep learning system. And, I guess Jingqi exemplifies that ability to get this up and running really fast. But perhaps, Tony, you can talk a little bit about what happened behind the scenes. I mean, we understand, okay, it's a deep learning system that helps you get up and running and you've got smart people. But what actually happens in terms of
Sorry, I hate to cut in.
day-to-day?
Acoustic system is really bad to the extreme extent that I even can't hear what you are talking about. So yeah, let me face you. So yeah, please repeat your question.
Hopefully you guys can hear us, right? Okay. So my question to you, Tony, is, it's obviously phenomenal that in 2.5 months you can get a system up and running onto the roads, and it makes sense that this is enabled by smart people and having a deep neural net that's working really well for you, having great training data set. But tell us more about what's happening behind the scenes in terms of what you got done in week 1, week 2, and how you get to in 2.5 months a system that's actually on the road.
Yeah, I think first of all, we are not, we're starting from scratch, 0 lines of code, but we have lots of knowledge. Actually, thanks to Waymo, Uber, and NVIDIA, many pioneers, they have already tell us roughly, there are something you can do. Like, of course, 64 lines of LiDAR have to be on top of the car. So we have lots of, I would call it a prior information or knowledge. So that part is easy, but difficult parts are, there are many things, it's so difficult to estimate. You have to do some really good prediction about which approach to try because you simply don't have enough resource and time to try that. In terms of that, you have to actually rely on simulator a lot. We are actually really made a very wise decision. That is, we focus on simulator. You see the videos, we focus on simulators a lot, and among 80% of our bugs has already caught by the simulator. So we got this kind of thing, this thing doesn't work or that thing should work. 80% of the time we have already know by using simulators. So that accelerates our developing speed to to an extreme limit. And also, the other thing will be actually the engineering culture. We really appreciate, our engineers to have a great culture.
No, and you raise a really good point on the simulation. Again, I'm going to sort of harken back to the video game situation, but some companies are actually using video games to create training data and using that simulation of Grand Theft Auto. And the beauty there is, of course, you have perfectly labeled data that you can use for that detection. One of the things we've done too is with advanced rendering techniques, we can go out and we can drive on a nice sunny day and then go back and simulate the rain. So you showed some of those rainy situations, but we can actually generate storm data, right? Rain on the windshield, snowstorms at night, at sunset when the sun is blinding. And so that becomes a really, really powerful tool to be able to generate this. But the other thing is we can do it in super real time. So it's not just 1 minute of simulation takes 1 minute, but using a rack of servers, we can generate over 300,000 miles in maybe just 5 hours. And so that gives us the ability to basically test algorithms on every paved road in the United States in just 2 days. And so we can continue to iterate, and our customers are able to really refine those neural nets and test all these cases in a very short amount of time.
Yeah, moving on from the technology behind these AVs to, I guess, the actual business models and getting them to the roads. I was, I guess, impressed by Tony's audacity and boldness in putting an actual timeline and saying this year this is going to happen and so on. And I guess it reflects the fact that in 2.5 months you get it on the road. So it's very aggressive timeline that you put out there. And I can understand the technology is there and the technology will get us there. But let's talk about consumers and regulators, whether they're ready for the kinds of timelines you guys are talking about. Let's start with the consumers. And I want to ask, maybe I'll start with Jeff, because you talked about 30,000 rides already. So how are consumers reacting to sitting in a car without drivers? What does it take to win their trust? Because this is perhaps the riskiest thing that you can give to an algorithm compared to recommendation and all these other contexts.
Yeah, I think it's been quite fascinating for us giving rides in Pittsburgh and Phoenix. That and one of the things I mentioned that, but just to be clear, you can't open your Uber app and say, I want the self-driving car. All you can do is ask for an Uber X, and if you get lucky, if one of those cars is closer than any human driver, then you'll be offered the self-driving car. And what's interesting is initially some people were worried a little bit about some of the things you said. Well, maybe nobody's going to want them. Maybe they'll be afraid. What we found was exactly the opposite. Almost everyone was accepting them and wanted to get repeated rides, and to the extent that we would see crazy things happen. Like, people would take out their phone and drive around in their car and chase one of our cars and keep calling for rides and canceling until they would get a ride with a self-driving car. So I think it's quite amusing that, sure, there will be some transition where people gain confidence in the systems, but I think the progression is going to happen relatively quickly. I want to comment on one other thing, the business model you brought up. There's one qualitative change that's ahead of us, and that is, right now, for you to just forget about it, get rid of your car, just take Uber everywhere. We'd be thrilled, definitely do that. But if you just run the numbers, for still the majority of the people, financially, it's not cheaper to do that than to own your own car. But once self-driving cars work, and they're everywhere, 80% of that fare goes to the driver, and in fact, a chunk of that goes to the capital, but much of it to the driver. It will become financially, it won't make sense to own a car anymore, and this will be just a sea change in how transportation happens for everyone. And in terms of business models, I think there's going to be a lot of trickle-down effects to just changing the way we all get around.
And you mentioned about policy. I think the regulatory side is really big. We're actually seeing really good movement on that. I was actually in Washington, D.C. this week, and we're meeting with senators, and there's basically been a lot of great work that's happening at the federal government level to ensure that there are the right rules being put in place to allow the testing and development, and also to prevent restrictions from being put in place. And the goal I think we all want is to have a unified sort of federal set of standards as opposed to every single state being different. That's going to be a nightmare if, from Uber's perspective, from Jingqi's perspective, from everyone else who's developing the vehicles, there has to be a different software stack times 50 just for the US, and then you have to start taking into account 2 other countries. So the more we can make sure we have a unified set of rules. And I think that's really the way the government's moving.
And I guess when we talk about regulation, let's talk about one of their concerns, of course, is liability. Another concern relates to security. And so let's very quickly tackle that. Security issues relate to, most of the testing is not in adversarial environments, but when you have it on the road running, you could face an adversarial environment. And one example someone gave me was, you stick a post-it note on a stop sign and the system might miss that it's actually a stop sign. So how does one think about security here? Redundancy is clearly one part of it, but how do you think about security as you think about, mass rollout of these systems?
Yeah, I think you mentioned one of those, certainly with the example of a post-it on a stop sign. Of course, there are many sources of information that will tell you that's a stop sign, one of which is your map that says there's a stop sign at that corner. So I think, in that particular example, redundancy really saves you there. And I think that will overall be the approach, to have redundancy in the sensors and the approaches to recognizing things. There's another thought experiment I like to do, though, in terms of just the safety. Are you willing to get in this car even though there's no driver? And the thought experiment I do is I think about what's the most dangerous thing we do right now routinely is probably how many of us came here. We get on an airplane, which if you think about it is crazy. Get in a big metal tube and light it on fire and point it at the sky. That doesn't seem like a very smart thing. And so why do you get on an airplane? What's fascinating to me is that there's a ton of formal analysis that goes into making sure that airplane is safe. And of course, in this audience, we're part of a subset of the population that could actually go through that analysis and understand a lot of it. But that's not why I get on an airplane. I just get on an airplane because they've flown a lot of miles and mostly nothing too bad happens. And I think we're going to see the same thing with self-driving cars. A ton of analysis and work will go into making them safe, but the proof is just going to come from the miles, and eventually people will accept that.
So I thought you were going to say something that I experienced when I was in Washington, D.C. this week, which was we get into a taxi, and some of these taxi drivers are just a nightmare, and so I'm happy to replace them with one of my computers.
So we have a couple minutes left. I'm going to try and see if we can squeeze in a couple quick questions, quick answers. One for each of you. What can we expect in the next 12 months or so before the next AI Frontiers conference? What are we likely to see in the near term with, I guess, not just your companies, but in this space in general?
Well, again, I think, as Tony alluded to, and we're just going to see it everywhere, more and more of these vehicles on our roads. I mean, out here in the valley where a lot of the companies are based, they're driving all over. I think we're going to see more testing throughout the country. We rolled out cars that went to Houston right after the floods because we wanted to get experience driving around flooded streets. We've driven through Canada to get snow. And so I think we're just going to see an explosion of the number of vehicles and really testing and getting training data everywhere because we're at the point where it's working really well, and we need to refine it.
So I want to actually, currently I look forward to see some final results about Tesla because in TED Talk, Elon Musk mentioned like by the end of this year, there will be a camera-based Tesla driving from New York, any parking lot, New York to parking lot in San Francisco by the end of this year. So I expect to see the final results without any human intervention. So if that will happen, I will predict probably there will be many camera-based solutions coming out, even more than what you have seen now. So I really expect to see that results. I still have hope that by the end of the year, if that thing will happen, that would be great.
So I guess one last question, which is, it seems like from your presentations, maybe the answer is obvious a priori, but I'll ask it anyway, which is the most likely format or model in which we are going to see autonomous cars on the roads at scale? Is it consumers buying autonomous cars? Is it businesses like FedEx and UPS deploying them at scale? Is it going to be pretty much just Uber, Lyft, which again is going to be a lot of cars, but these kinds of companies. So we're almost out of time. Maybe a quick line or two from each of you.
I think it's all of the above. I mean, there's so many companies. Like I said, I mean, we're working with 145 just startups in this autonomous vehicle space. So you're going to see, you know, robo-taxi car sharing services. You're going to see closed geofenced areas like at airports or at Disneyland or something like that. And you're going to see trucking, a lot of automated trucks as well.
Yeah, exactly. I just echo what I say earlier. I think there is going to be a lot of different vehicles involved, a lot of different systems involved. But the one thing is that there really will be a change. Is it will not make sense to own a car for yourself that you only use 4% of the time anymore. And I think people will get away from that mode, although there may be many other modes that replace it.
Well, so I think we're out of time. I have to say that not only was this a very interesting session, it was different in one other sense. This is the only session where everyone on stage has a jacket on, which, you know, when I wore the jacket...
Next time I'm bringing a hoodie.
Yeah, when I wore it this morning, I feel like I'm going to be way overdressed, but not in this session. Anyway, thank you all for being here. Thank you to the speakers for joining us. Thanks.